Hey guys, so 7.2 areas between curves. What we're looking for here is bounded areas. So the thing is, and I mentioned it before, is we've already been doing this. Actually, we just haven't realized we've been doing it. So for example, let's say you have this function x squared, and let's say you're trying to find the integral between 0 and 5 of f of x in terms of x. So really what you would be finding, you guys know, is between 0 and 5 on the x-axis, you're finding the area under the curve above the x-axis, right? So that's what you've been doing. So what we haven't been writing, which is actually what we've been doing, is we're finding the area between f of x and the x-axis, which has its own equation. The x-axis has an equation, y equals 0. So technically we're doing this. We are subtracting 0 from the function on the top and then d of x. So we're subtracting top minus bottom function, which is what that says, right? So that's the same thing. So we've already been doing this top minus bottom. Just think y values are bigger on top than the bottom. Okay, but sometimes now we're going to be talking in terms of y. So if you're in terms of y, then it's going to be y values for your limits, and also you're going to go from right to left. How come it's right to left? Because if you think about so this is top to bottom, right? Minus the y equals and the y equals. So subtracting y equals and y equals. Well, if you're doing in terms of y, then it's going to be x equals and x equals. And on the x-axis, you're more positive, you're bigger on the right than on the left. So it's going to be bigger minus smaller. Normally that's how it works, okay? So how do we do it? We do these 3 steps. Really, it's step 3. But I want you to be able to graph it, and in order to graph it, it helps to have intersections or solutions to the system. So for example, 1, how do you solve this? Well, how do you solve a system of equations? You set them equal. You use substitution, or you can use eliminations. But I'm going to use substitution, so set them equal, and then factors, like set them all equal to 0, factor, and then you get these 2 values for x, and then just remember that really you want solutions. Solutions are points. So these 2 equations give you these 2 points of intersection, right? If you have a parabola and a line, so think about a parabola and a line, a lot of times it crosses maybe 2 times. It doesn't have to cross 2 times, but this one crosses 2 times. Okay, so we're going to go ahead and graph that. And to graph that, we look at this and we go, okay, I know I need to go, higher on the y-axis and then left and right on the x-axis. So you just draw it that way, and then you draw the best you can. Draw it really neatly, as neatly as you can. Make sure your tick marks are nice and uniform. And then what you're going to do is, you don't know what's the top and bottom before you highlight. So you're going to draw it. So draw those points first, and then look at your functions and go ahead and draw the functions so that they, match up with your intersection points. And then once you highlight or shade it in with your pencil, cross-hatching, then you go, okay, is this an x or a y? Is this in terms of x or y? Well, these are both y equals blah, 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 x. So these are in terms of x, okay? So what are in terms of x? So now I have a top and a bottom. I look at my blue and I go, okay, what's the top of the blue bounded area? So the top is going to be that line. So that's why I labeled that my top. My bottom is the parabola. So if I subtract the line from the parabola, I get all of that blue, right? That's how I get all the blue. Okay, and then I just go ahead and set up, and that's my setup. So from -1 to 2 on the x-axis, and then here's my top, here's my bottom in terms of x. I leave it like that, and for this one, you had to, did we solve it all the way? No, I told you didn't have to, but you should be able to, right? So that's the beginning of it, and the other ones you have to solve all the way, okay? So you should be able to solve this, but when you see a fraction, you should do it by hand, so practice doing it by hand. When you see a decimal, go ahead and plug it into a calculator, it's fine. All right, let's try another. So for this one, you're gonna, number one, solve. So how do you solve? You know, substitute whatever, right? So y equals, set them equal. Sine x equals 1. When does sine equal 1 on a unit circle? You have a y value of 1 when x equals pi over 2. So pi over 2 comma 1. And then you also have x equals 0. Well, when sine of 0, when you have a sine of 0, what's the sine of 0? It's 0. So 0 comma 0. All right, you have two intersections. You're going to draw the diagram of a sine graph, and you go all the way to y equals 1, and then you start at x equals 0. Okay, so the graph looked something like this when we drew it. And then you have to decide, so you'll graph something sometimes and you'll see and you'll be like, oh, this is what I should shade. But this is not what you should shade, because you have to realize, yes, you want to touch the sine of x. So yes, our blue or whatever you're using should touch that curve. But you also want to touch y equals 1, which is really a horizontal line. So your blue should have a horizontal line on top. And then x equals 0, which is the y-axis. So your bounded area has to literally be bounded by what they want around it. Bounded means like boundary, right? You want to have a boundary around it of these equations. Okay, looking at the blue, I can see the top of the blue is the line y equals 1. The bottom of the blue is the curve y equals x squared. Okay, so then we go ahead and fill it in. This is in terms of x. See, y equals a bunch of x's. And then I can look at it and I go, okay, what are my x values? This is the lowest x value of my blue. This is the highest x value, so 0 to pi over 2. And then top minus bottom. And then you should be able to take the antiderivative and plug in. So then you did that, and you showed your work for it, and then you got pi over 2 minus 1. I keep writing unit squared because technically, if you're finding an area, you should have some sort of unit squared. If you don't have that, I don't think it'll get marked wrong or anything, but just realize that area is a positive, you know, unit squared. Okay, the next one is a little bit different. So for the next one, it says x equals y squared minus 4. That's definitely different. And the y-axis. Realize that the y-axis is a vertical line. Vertical lines are x equals. So x equals 0 is actually the equation that gives you the y-axis. Just like right here, how this is x equals 0, right? So that was the boundary for that question. Okay. So now I have x equals x equal. I can set them equal, and I can solve, and I can get my 2 points. So solve for x, I get plus or minus 2, or sorry, solve for y, I get plus or minus 2, and then my x was 0. So 0, comma, 0, comma. All right, you're going to go ahead and graph that. Oops, I showed you everything. You're going to go ahead and graph that. And then how do I know that this is a negative 4? Well, I knew, you know, the parabola went through here. It's a left-right kind of parabola because it's y squared. How do you find the x-intercept of anything? You plug 0 in for y, and then you get x equals negative 4. So there's my negative 4. I graph it. So my boundary is this parabola and the y-axis. So I shade it in. And then I look at this, and I can tell this is x equals a bunch of y's. So I can tell that this is a dy. This is in terms of y, which means that my limits are also y values. So from the very bottom of my blue to the top of my blue is negative 2 to 2. And then this is going to be right minus left. What is on the right of my blue? It's this line. That line is x equals 0. So 0 minus, what is the left side of my blue? The left side is the parabola. It's x equals y squared minus 4. So y squared minus 4 is the left side. This is the end of the setup. If I said what's the setup, you would leave it like this. You don't have to simplify anything. Okay, you would leave it like this. But then if you kept going, which you should, you'll get some sort of answer, and your answer I already told you, but here's your work for it so that you can check. Okay, so 32 over 3 was your work. Okay, last one on the back. Last one is definitely interesting. So here's why it's interesting. So you had these two, and you're going to start with, and then you have to think for this one, I didn't list it. What's your first step? Solve. So set them equal, and let me tell you what people like to do. Are you ready? So this is what people like to do in their first step. They're like, you know what? I can divide by x minus 1, and I get x minus 1 squared equals 1. Oh, look, I'm so clever. I get this. And I'm like, okay, good job, good job. So if you do this, let's keep going. You would get x minus 1 equals, and then you take the square root, and you get plus or minus 1. Be careful, it's not 1, it's plus or minus 1, because you're the one doing the square rooting. All right, and then you get x equals, you add 1 to the other side, so 1 plus 1 is 2, and then you add 1 to the other side, negative 1 plus 1 is 0. All right, so you get these two answers. However, this says x cubed. X cubed should have 3 answers for x. So you just divided away, when you divided away the x minus 1, you divided away one of the answers. That's no good. So your first step actually should be subtracting to the other side, and then after you subtract to the other side, you have this factor and this factor that's the same, so you can factor them out. And then what you get left is a quantity squared, and then in minus 1, because you factored this out, and you get a 1 left over. And then now you have 2 factors. You have this one, and you have this one. This one can be set equal to 0, and this one can be set equal to 0. So you set them equal to 0, and you see, oh, this one is what I found, but this one is the one that I divided away that first time when I did it incorrectly. So that's why you don't want to divide things away. You're going to miss one of your answers. Okay? Okay, so you have 3 x values. You got to plug them back in so you get some y values to go with that, because you need points, remember? So plug these into either equation. This one's easier. And then you get those 3 points. And then you graph those 3 points. And when you graph the 3 points, you get something like, I just want to show you really quick, you get something like 1, 2, 3. You get that, okay? So after you get that with those 3 points, then this one's easy to graph. Go like that. Oh, done. I'm done. Oh, shoot. You don't get that. Sorry. Just kidding. You get this. How do I know? Because it says x minus 1. So it shifted down 1. Okay, so you get this. And then what would that be? So this is tricky for some people. So realizing that x cubed is normally, an x cubed looks like this, and then it goes down the other way. What does the minus 1 mean on the inside? It means I shift to the right. So if you shift this to the right, it looks something like that. So that, if we draw it a little bit bigger, a little bit nicer, is what I have right here. Okay, so here's the thing. I can't technically call this the top because over here, it's the bottom. And if I call this the bottom, over here, it's the top. So the top and bottom switch places at 1. So if I try to write an integral from 0 to 2, from the x value 0 all the way to x value of 2, and then I put one of these, I don't know which one, so x minus 1 cubed, and then I try to subtract the other one, you know what I'll get? I'll get 0. And that is totally not true, because there's obviously area here, so it's obviously not 0. Why is it 0? Because this area and this area are the same, but negative, because it's subtracted the other way. So instead, we can write it this way. So we can do 2 times 1 to 2, and then using 1 to 2, I'm saying now that this is my top, which is x minus 1, y equals x minus 1. And I'm saying this one is my bottom, which is the x minus 1 quantity cubed. So now my top and bottom, I'm just using this part from 1 to 2, from 1 to 2. And then I have top minus bottom, and I'm multiplying it by 2 because I know this area should be the same, only because I know that for the line and the x cubed, it's like totally symmetrical along this diagonal, right? If it's totally symmetrical, then those two areas should be the same. So that's why I can multiply by 2. Does it always happen that way? No. Sometimes you're going to have to go from 0 to 1 and then go the other way from 1 to 2. But for these, I know that they're going to be the same. Okay, so there you go. And then for this one, I said you could just write the answer. It's fine. So you should just be able to plug this into your calculator and get that answer. Okay, one last thing is, if you were to plug this into a calculator, there is no Y button. You're not going to press Y. So technically, on a piece of paper, you got to write it like this with the Y and the Y over here. You have to say this is in terms of Y. But to get the answer on a calculator, you would just do it normally using the X. And you would lie to the calculator and you would say, oh, I'm in terms of X. So I'm going to put, you know, -2 to 2, and I'm just going to put an X squared and then an X over here. So you would be a big fat liar, but that's okay. All right. So on a calculator, you put X's, but on your paper, it has to be in terms of Y. All right. Okay. So good luck. You're going to try a couple for the homework, and then let me know how it goes. I'll see you later.